Nice.
Hi, Dennis.
Hi everyone.
Great talk.
Hi guys.
Yeah, thanks.
So it's been quite a day. Let's do a roundtable. Like, what was the one thing that you were like, wow, I didn't know about this particular topic, and I came away from today learning something new. Start with, who wants to go first?
I want to start because I think I maybe have the least interesting, but still real facts that are just challenging these days. I would have loved to see more of the talks, but unfortunately, as maybe some of you too, these virtual conferences are not the same as physical conferences where you can sit there and see everything. So I'm really much looking forward to the recordings. I assume they will be published on YouTube. Right?
Correct, yeah. In the next 24 to 48 hours, there will be a YouTube.
Yeah. So my quote-unquote real life caught up with me. I saw a little bit of Neil and a little bit of Denis, and Stefano, I know your stuff because we've been working closely. I have to say I really love the stuff that Stefano is doing with their AI-powered optimization, because I agree with him. There's so many permutations of all these different things that we can tweak. And just as I said, with the pattern detection, things we can automate, we can also use this level of automation to optimize things that no human being can optimize, right, in a meaningful time. So this is why I'm really happy about this.
Thank you, Andy.
So I really like Lawrence's stuff on measuring and benchmarking these programs. I think it's very easy to take a benchmark and for it not to be true. And I've seen that paper where they change the environment variables and suddenly the program goes twice as fast or not. So to see him, checking thermal counters, restarting fresh processes, rebooting the machine between each run, and then after you've accounted for all of that, there's still loads of things that just make any benchmark results you have completely meaningless. So throughout the day, there was the persistent theme of profile it before you do anything, measure before you act. And we also found out that you can't really measure very well either. So I kind of see that as the kind of ultimate quandary. Sometimes you just have to do optimizations because you think they make something fast, rather than because you can prove they make something fast.
Yeah, and to build that, Laurie had to give in actually to the benchmark. He had to do something that he thought was wrong, but the benchmark said it's right. So in order to get his code change approved by the community, he had to do the wrong thing, which is crazy.
Yeah, that's also it was mentioned also by Denis, the fact that all the hardware is actually being designed more and more to achieve the top performance. But in the end of the day, it's also very important to achieve some kind of sustainable or predictable performance, especially the current days where we are more and more actually including performance benchmarks and testing in the CI. So actually being able to identify the performance regression in our systems, it's very, very hard if you have all this performance variability that is happening also on the cloud. It's hard because actually all the stuff that Lawrence was very great talking about, it's hard to, for example, implement them on the cloud where you don't have access to the underlying hardware. For example, on AWS, we did lots of benchmarking on those aspects too. On AWS, you need to buy very big machines to be able to control, for example, CPU P states and all the power management features, but you don't get to see any kind of such stuff. For example, if you work on containers or even less on serverless, you don't have pretty much any kind of visibility. And we have also used lots of serverless services. They are very convenient. For example, database as a service, but we are seeing the fact that all of a sudden you get this performance cliff and you are wondering what is actually happening. I am running just simple queries and all of a sudden everything slows down. So they are very convenient on one side, also the containers, etc., but it gets us much far with respect to the underlying hardware and the possibility to have repeatable and predictable performance actually.
Yep. So from my side, yes. Sorry, I was sleeping, right? So I pretty much missed all of the talks besides mine, of course. but yeah, I'm looking forward for recordings as well.
But it's an honest answer, at least, right? So the people, the attendees, will now see that we are honest people in the panel. And if we say we don't know things, then we say we don't know things because we don't.
Sure,
know
of course. Yeah, absolutely.
But maybe one additional point to this whole discussion, because I think this is fascinating, because some of us are approaching performance from a different perspective, right? One, we are trying to optimize everything from the bottom up, where we try to optimize the hardware. And then if we squeeze out 50% on the hardware, that's great. But if a developer on the top is just implementing an algorithm so completely inefficient, to use the right word, then all the optimization on the bottom doesn't give you anything, and you lose everything. This is why I think a bottom down, or a top down and a bottom up approach, the combination of both things is so important. This is why it's great that we have panelists or folks here that share knowledge and experiences from both sides of the optimization end.
Sure. Yeah, absolutely. However, I also want to point out, I think that any of those layers cannot just stop providing performance speedups, right? Because what will happen otherwise? Otherwise will happen the situation where every developer will be a performance ninja, right? And this will not happen, right? Because so what do I mean by that? Is that if all the performance will come from the application layer, from the top, right? So then we'll have a whole bunch of ninjas. But this is so hard, right? For essentially for squeezing the last bit of performance from your software is hard, right? Ninja performance is hard, and the gap is growing. So yeah, we cannot stop performance improvement in compilers. We cannot stop performance improvement in hardware. So
what we can do, and I think we are doing this, all of us, we can try to figure out how can we take what we know, right? And if we call ourselves ninjas, then how can we as ninjas automate the stuff that we know into tools, frameworks, whatever it is, to at least allow everyone out there, maybe at least 80%, let them through automation find and optimize 80%. And then the last 20%, this is still something for the ninjas, and there's only a handful, right? But still, we can achieve a lot through automation and baking this into our platforms, into CI/CD and things like that,
Yeah, that is spot on. It comes back to the question of scaling we alluded to earlier, which is I think the ratio we have in Facebook is probably 1 to 100. So for every 100 product engineers, there's one performance engineer. So you cannot scale by doing everything yourself. And you have to come up with, like you said, the tools, the processes, so that the product engineers realize what the problem is. And most of the times they will fix it, but they have to know how to root cause that performance problem.
Yeah. And I guess the other thing, at the completely other side of the spectrum, I know for me, I learned software engineering in high school. So in Austria, I was fortunate in the 90s to go to a high school specialized for software engineering, but performance was not a topic at all, right? And I'm not sure how it is today in these classes, in the school and maybe at colleges, universities. And I think this is something that we also need to address. How can we educate people, at least a common sense of performance-driven engineering, right? Don't think about the next shiny, CSS style, but also think about what happens behind the scenes and what other things do you need to look for in order to make this performant.
I guess I'm less convinced. So, a large part of computer science is complexity theory, which to me is kind of like the first order differential of performance. If you write an exponential algorithm, it's going to be slow no matter what. So, I think that is the thing that's well taught in most computer science degrees. Once you go beyond that, with things like Rowhammer, Meltdown, Spectre, what is fast and what is slow has changed over the last 5 years, and quite dramatically. So things like an abstract base class, well, it always had a performance cost, but now it has a really significant performance cost. And then in 2 years' time, when the new chips come out, maybe they'll fix it. Maybe the compiler will get better at devirtualizing. So maybe it's more tooling that we need to teach people to use their tools, but actually teaching people what's fast and what's slow changes so regularly. Yeah.
Yeah, we see that a lot because we also work with lots of universities in Italy. By the way, we started off as 20 years ago. Our company as a spin-off of Polytechnic of Milan, which is one of the leading universities in Italy. So I do a lot of talks at universities, and what we found is that actually this kind of classes are not really taught anymore. So the students are very interested to learn that there is this kind of field in the industry where they can study the performance, but they are not really being exposed also in the classes. So it's something that we need to fix it.
And then my question to you, Stefano, is, I mean, it's great that we also have a university here in Linz, some really good schools, but then if you look at the world, we are on such short supply of real engineers that come out of universities, which is why we have to obviously see a lot of people coming in the industry, but they don't go to university. They check out some YouTube tutorials and then they, start hacking their next app together. The question is, how can we also reach them, at least with the basic understanding of performance? And I'm not sure if performance on its own is sexy enough. I think you probably need to somehow, I don't know, maybe it's more like, what's the business impact of bad performance? And it's not about just that you're losing users, but it's also about that your cloud costs are going to skyrocket and you will never build a sustainable business if you don't think about performance, at least the basic concepts of performance engineering from the start. So I really wonder how we can reach these future engineers that are not coming through university.
Yeah.
So one thing that I think Denis was doing right is kind of creating these competitions, making it cool. If you manage to get the young crowd that is doing all these hacking competitions to look at performance just like another way of hacking, I think there will be a cool factor next to it. And you're right, there's the business, the hard cash argument that should be very, very convincing as well. I think the coolness factor would go to things like what Denis is doing.
So make performance cool again.
I don't know if you guys have other ideas on how to make it, how to reach out to the entire population.
Well, I think some aspect, the open source thing makes performance a lot harder. Before, you had your little monoculture, and if there was a performance problem in it, you could, there was a vendor to blame, there was a vendor you had a contract with. With open source, in some of my projects, I might pull in 1,000 libraries. And if any of those 1,000 libraries is doing something the wrong way, I suffer. I mean, there was an example I found. One high-performance HTML parser was jumping out to a low-performance HTML parser to do some CSS validation. And in this case, I even wrote the low-performance HTML parser it was calling out to. So it was entirely kind of my fault or their fault that they'd used my stuff, and my fault that I was using their stuff that used my stuff without them thinking about it. So you kind of get this very complicated pile, and it's hard to know whose fault. And also, if you can even expect high performance from an open source project that you haven't paid for, and it does what it does well, it's just performance isn't what it does.
Well, but I wouldn't. Well, I of course I understand your argument that you maybe expect more from something you paid for. On the other side, shouldn't we held? Isn't all software equal in the end? We should held the same. We should keep it or measure it against the same standards. And therefore, I don't think that open source should be. We should see it as, let's say, less quality or lesser performance. I think this is.
Oh,
maybe I got you wrong, but
no. So I definitely wouldn't say that. I often find open source software is indeed higher quality. I guess with open source you end up depending on more, and for some open source software, the focus was never performance. They never claimed to be fast. They claimed to do something cool that you couldn't have done otherwise, and performance just wasn't relevant to their use case. So it's harder to, persuade someone that this is relevant, especially if you're just saying, please do this work for me for free to make my cloud business faster. No, it's not super fair even.
Yeah. So what then?
Sorry, I'm going to be a bit of a troll, but I wonder if, to your point about making my cloud business faster, if cloud providers don't have a perverse incentive to have less performance software part of their offering.
Yeah, I guess yes and no, right? They may, but on the other side, they also need to scale, and they cannot build the next data center out of nothing. So I think they also need to figure out, because I think in the end for them is more customers giving them more money or fewer customers that have shitty software running? That's the question in the end.
I think there is a cloud business model where they do take things like Postgres and create managed instances of them that have higher performance, so you can pay a premium on the per hour cost to get higher throughput. So maybe, if you could sell performance with $1 cost in all cases, that would be the way to motivate performance.
Yeah, I remember years ago that there were also papers in a way telling the story about, for example, AWS data centers that were built using very cheap processors for cost reduction reasons. And when you spawn new VMs, you basically didn't actually know which kind of hardware they were running at. So there was an interesting paper that was showing that, for example, you might end up on latest Xeon processor or even some AMD desktop processor without any equal probability in a way. Then, of course, on due to the fact that the performance started to be more visible, more benchmarking was done, that was fixed. So now you have more, in a way, visibility about the kind of hardware also you will be running at least on some kind of services, infrastructure as a service, etc. If you move to managed services, serverless, etc., containers, now you have this kind of serverless containers where you just run your container. You don't actually know anything about the clusters. What are they running? So what's the actual hardware? You don't know anything about that. So that is, I think, those services are very compelling for the developer experience. So they are much in a kind of very exponential growth. But on the other side, it's this kind of you lose lots of control from a performance perspective.
One other thought, because earlier we talked about how can we, I think Neil, you said, right, if I now build software and I have like 100 libraries or 1,000 libraries, how can we even know if something is potentially problematic? In security, there's a solution for that, right? There's like these known vulnerabilities, and you get these vulnerability scanners that tell you, hey, this library that you're using in this version has this vulnerability. Do you really want to ship this? What if we, as an industry, as performance engineers, try to figure out how can we build a database of well-known performance problems in particular libraries, and then the only thing we need to do is we need to build a plugin into Visual Studio Code or some other IDEs and say, hey, developer, by the way, these 5 libraries here have potential performance implications. And with this, educating people and making them aware.
I think that's an amazing idea, and it builds on your point about the 8 patterns that were disappointing to you even after 20 years, right?
Exactly. Yeah.
Maybe come up with a maturity model where you say, here's the 5 different maturity levels in terms of performance that each library can be at, and you start like a certification process where you say, this library is certified like the energy on your washing machine. This washing machine is A. This washing machine is B. You probably want to go for A, if you can.
Yeah, need to make some notes.
Yeah, but actually, I think it's a good position to drive that, because I think if through Captain and through all the evangelization work you're doing, you could be a good and, I should say, independent proponent of a maturity model for performance.
I guess I worry that you just end up slapping a D on all Python code, a B or C on all .NET code, and an A on all Rust or C++ code. Because it's a significant overhead, something like Python. I mean,
well, the question is against what you measure it, right? If we know that, let's say, certain runtimes are just they have a certain base, I don't know, expectation, then I'm not measuring it against the fastest runtime in the world, which might be written in a different language. So I think it's.
I guess the weird thing I see is that something like Python JIT is, the standard one, is relatively slow if you compare it to something like Lua or JavaScript. Whereas, my intuitive sense is Lua is a lot less popular, but it's had a lot more money invested in it. So I've always felt that the kind of performance of CPython seems odd in comparison to its popularity.
Yeah, let me plug in. So maybe actually another approach would be not to create a database of bad software. Maybe we can create a database of let's say golden standard software. Okay. So and what do I mean by that is that we can have a database written by performance ninjas of snippets of code, right? With and every snippet will be let's say classified with its own semantic meaning, okay? And then we can and if we solve the code similarity problem, and well, there is already early evidence that we can. So we can build the recommendation systems for people, right? So for example, imagine someone is writing like the bubble sort, right, on flight. And it will so the let's say the tooling side will go to this database, right? Will parse the code that was written by human, right, just a few seconds ago. Then it will go to the database. It will search the similar code with the same semantic meaning, right? And it will recommend to the programmer, right? So let's say the performance. More performant version of the same code, right, written by Ninja. So, I mean, what do you guys think about this?
Do you think this kind of approach will work for any kind of hardware architecture? So due to the fact that you will never know which kind of system the code will be running, do you think that we can even define a kind of best top performing algorithms, or it's too dependent on the workloads, too dependent on the actual environment?
Well, I don't know.
I guess as long as you can abstract it away to a function and you have relatively low abstraction costs in your language, I don't see why it wouldn't take the bubble sort and just replace it with a single call to sort. And that single call to sort certainly could be tuned per architecture and do the right thing and have cache thoughts applied to it and all the rest. I guess.
Okay, this is probably something that should be done by the library maintainers, I guess.
Yeah. There is some aspect though of what's the performance overhead. So if you're in Python, passing a function to the sort, that's probably going to be the slow bit, assuming they've written their sort in kind of low-level optimized C. Calling your comparison function is going to be the slow bit. So I guess I worry if languages which have an abstraction penalty are going to be able to take advantage of abstraction to get the performance.
Yeah, and maybe it's really just about not the language and the runtimes itself, but really more like somebody's writing a library. I'm always referring to Hibernate as a great example where we've written countless blogs about the performance problems of Hibernate, not about Hibernate itself, but if you use it wrong. And then maybe just having people that are basically saying, hey, I found this problem when I used this library in this way, but now I want to make folks aware of it. And maybe this is something that then ends up in this type of database so that I can read up on, hey, for this type of library, here are the 5 things I ran into, and please watch out for them. 2 of them are already fixed in this latest version. 2 of them can never be fixed. It's just a matter of how you use it. Plus at least some recommendations on on how to use certain things, because it's, as I think Neil, you said it right with your two parsers. One on its own might be perfect, but the way they use each other might be the problem. So you want to make people aware of this. And this also goes into my pattern talk, because my pattern talk was not about that the database is slow or the application code was slow. It is the way the application code is accessing the database. That's the problem. So I could not blame it on either side, but I can blame it on the way these two services talk to each other. Yeah.
I guess in the good old days, people would have written blogs about the library that said, don't do this, or this works well. Whereas it feels like now we've kind of moved to more ephemeral communications, things like Twitter, which are a lot more, here's a thought, but not enough context and not enough information that you can apply it later in future. So I wonder if a while back there were Usenet groups that had exactly this information about most of these things. And then there were blogs that had it to a lesser extent. And now there's Twitter, which has it even less, and some Reddit posts. And I wonder if we're losing that over time.
This is another argument where we need a centralized performance database of whatever that looks like.
Yeah, or if GitHub is where it's at, maybe have GitHub introduce performance as one of the dimensions each project is evaluated on. Maybe that's an easier thing to set up rather than start from scratch with the performance database.
Mm-hmm.
Well, I mean, GitHub already, opens pull requests for you with upgrade this library because it's insecure. You have these vulnerabilities. So, if it had the performance database, it could do roughly the same thing for performance.
Exactly.
We could actually, I'm happy to take a couple of actions, and we can try jointly to reach out to these people. I can probably find someone from GitHub that can listen to us. I think that would be an interesting cooperation. I see Neil laughing in the background. You don't?
That would be great.
I think if the database was available, high quality, and kind of the de facto standard, I don't think you'd even need to ask. They'd probably do it, just off their own bat. In the same way that, like, the security databases, NPM audit, cargo audit, most of the package managers have added a security audit feature.
Mm-hmm.
So I guess Andreas, probably, if I read Neil's argument correctly, is how would you build this database of performance? Because then it would be easy to get people to consume it. Is there a body of performance? Is there like an IEEE of performance out there?
Really, there's just a couple of performance, I think, enthusiasts around the world, like we, that are organizing ourselves on different events, but I don't think there's a real body around it. But I think Stefano, at least, I've known Stefano before, and we've been into some of the similar groups, whether it's there's
ICP, an International Performance Engineering Conference. There are some, which is an ECN conference. It's more on the kind of theoretical stuff that, from what I know, at least.
Yeah. Well, I will. The question is really, who should we? I will definitely bring this up internally within our organization, because I know we have a lot of performance enthusiasts, and also we are building a performance monitoring observability platform, and so there might also be some interest just to drive this from our end, and then obviously reach out to the community, because it should not be driven by one vendor, but at least it needs to start somewhere. Yeah. But I took some notes.
I think if Laurie were here, we could ask him which benchmarks you could use even, because I think that would be another kind of worms. Got the benchmark that you can trust. But we have to start somewhere. I think the first step is always the hardest. Then people will be able to take it.
Mm-hmm.
Okay. I'll definitely follow up on that. And another follow-up I want to do with Denis is around bringing performance challenges into TF competitions. All right, that was a good first question. Let's see if we get this. Anything? Okay. All right, then let's see. I think the second, another big takeaway for me was really the fact that we have all these layers, and I think Denis, you had it in your presentation as the know your stack. How is that scalable? Do you think? I mean, on one hand, I would say it means that there's no success at the end of the tunnel, right? In a world of more and more virtualization, abstractization, it means that you cannot expect a normal product engineer to know its full stack. So therefore, we are condemned to a world of mediocre software, performance-wise.
Well, it's a hard question. And I think that this is more of a tooling side again. So I mean, so what you were referring, I guess, is that, you know, yes, it is hard to write the heterogeneous software, right? It is extremely hard, and write performant heterogeneous software. However, I think, you know, and actually, so this is actually the project that I am working on right now. So it is a heterogeneous compiler, right? So at Intel, right? So it's called One API, and the idea is that to we envision the future where we can program all the devices with just one API. So it's essentially, right, and then there will be there'll be, let's say, a front-end compiler which will just, you know, parse the code, and then there will be like all the back-end compilers. So the problem here is, like, you know, to bring all the vendors and support this API, right? So I mean, I think it is still possible, right? You know, to generate let's say the optimal code for all the platforms out there, right? So well, if we will have all the backend compilers, right, you know, working properly, and, you know, and generating optimal codes, then I think it's possible.
I am a lot less convinced. So I think the reason software has done so well is because we've added lots and lots of layers of abstraction. You know, I don't need to know about how electrons work, how transistors work, how nanocode works, how CPU instructions work. You know, if I'm sitting at the top on, say, Python, I know very little about what's below. And that allows me to reason about what my software does functionally, but stops me completely from reasoning about what it does performance-wise. And I think, you know, as you see, like, you know, I'm an old school software developer. So when I say the top of the stack, I mean something like Python. Nowadays, someone means a Kubernetes cluster running something, which is even further removed from just the idea of physical electrons running on hardware. And I don't see how people can, you know, I don't see how we can both keep pushing people up the stack with more abstraction and let them see down to the lowest levels of performance.
Yes, I agree, because I also see of course, I may be a little bit biased, but I see that the tool could be an automation here could be the answer, because actually the trend is pretty clear. So we want to ship faster. So we want to leverage higher level APIs. So I don't see this kind of trend, at least in kind of general purpose applications. Of course, it might be different if you are talking about, I don't know, embedded system or something like that. So another thing that we have built within our platform is the capability, a sort of plugins that know the different technologies of the stack, and being able to use AI to optimize all of them without the developer or the performance engineers need to be expert on all of those. And The thing is that besides what today I've touched just the surface about the JVM, but we have done, for example, optimization of databases and what we have seen interesting, another kind of interesting effects where, for example, in order to speed up the database, which is the top layer in your application, you actually needed to slow down the operating system. For example, the storage performance. So if you had just looked at one layer and you wanted to optimize just that single layer, because even for example, you might have this kind of expertise, you might end up slowing down the application that is sitting 2 layers on top. So this is actually getting so complex, which it's becoming, I guess, too complex for today's developers, because they certainly don't have this kind of skills anymore.
In the meantime, Alex Kachur just mentioning that the next ICP conference is in a month. Actually, share the link probably on Twitter afterwards. So that's good to know what that buddy is doing there as well. Challenge.
So I guess I've got a question that goes back to what Stefano was saying at the beginning. How can we do performance on CI, which seems like a necessary thing, but is not something I've ever successfully done?
Okay, that's a good topic. That's a big topic, I guess. Yes. So I don't know. Do you have any specific problem that you had in mind for?
Let's say I've written a large IDE. I'd like it to not slow down, and when I write in something that says performance improvement, I'd like to check it really did improve the performance and then doesn't regress in the next patch.
Yeah, that's a common problem. So I see a couple of themes here. One for sure is the noise that we have in our environment. So this is a big problem, as we are doing lots of work in our lab to understand again if an optimization is actually reproducible. And there has been a great talk that I shared recently about MongoDB performance engineering team. By the way, they published a paper on ICP, actually, I guess, about change point analysis. So something that also Lawrence this morning touched about. So some newer statistical method to being able to detect some kind of change in the performance. But of course, in order to be able to apply those kind of techniques, you need to have some kind of stable measurements. So for example, another blog post that they published on the MongoDB performance engineering blog post was about, again, some kind of tunables that they have found out on AWS instances that could actually bring down the level of noise significantly. So for example, they discovered, for example, that they needed to turn off some again, CPU hyper-threading settings, or they discovered that, for example, depending on the storage, the kind of storage volumes that you are provisioning, you may have lower noise. For example, they discovered that EBS, the remote storage options that you have on AWS, are actually the more stable than the local disk. So this was a kind of surprising result. So again, this is kind of challenging in my opinion. I also wanted to hear Andy's opinion, because I know that you work a lot also with Cat and on the CI. What's your experience in real life applications?
Yeah. So what I talked about today was really giving developers a tool that whenever they are committing code and that triggers, a CI pipeline that first, let's say, builds that artifact. And with Captain, we provided the automation around taking this artifact, deploying it into a dev environment, and then running some very basic performance tests. And in this case, I really talk about very basic tests. This can be a 3-minute JMeter test with 10 virtual users. And it's not about finding, hey, is this code now 10 milliseconds faster or slower than before? It's also about finding all of these patterns that I talked about. Because if you are developing and you want to get fast feedback, did I just include a new performance regression? Then I'm talking about these patterns that I see constantly. Like, hey, I updated a library, and this library now is causing twice as many database calls to my database that I didn't have before. And as a developer, I didn't even know about it because I'm just using this library to make database access easier. And because of a new flag that I didn't set, now the library is bypassing a local cache. And these are things I can easily find out with very minimum test effort, and also with not very complex test scripts. It's just about, as I said, pounding the artifact that you deploy with minimum load, let's say for a minute or two, and then you can detect patterns based on these metrics I talked about today. And we see, I mean, I've been talking about this, and I looked back in 2008, I wrote the first blog post about using monitoring metrics in CI/CD for detecting problem patterns. Back in 2008, unfortunately, nobody really had any good automated CI with automated tests. Now, I'm not saying that in 2021 it's much better, but it is a little bit better, right? So we have definitely better CIs, more automation, and at least a basic set of, hey, I know how to code a simple performance test using Postman, using Locust, using JMeter or whatever. And now what we are doing with Captain, we are providing the orchestration layer to connect all these tools, to connect your CI with the testing tool, with the monitoring tool, analyzing the data, and then giving you a very easy to consume result. And that's what we are trying to solve with Captain. Right? And hopefully this will have an impact. But we're not solving what we don't solve. We don't solve the, how can I squeeze these 5 milliseconds because I need to optimize these assembler instructions. This is not what we're doing here. Right? We are reaching on the, we're starting from the top end and on the application development.
Makes sense. Makes sense.
I guess the projects I've been in, they tend to kind of every so often someone will squeeze a little bit of performance and we'll lose it all on commits that kind of change a comment and change a constant that no one thought was performance sensitive. So I guess if you could just not lose performance, that would probably be a significant help.
Yeah, and then it just integrate these things, right? These what I just said, integrate a tool like Captain into your pipeline. Every time you make a configuration or deployment change, just run your simple test and then let Captain look at key metrics that you have optimized earlier for, and just make sure that they are not degrading. And one of the things we built in, you can do two things. You can have Captain validate your individual metrics, like we call them SLIs, like we are kind of aligning with Google Site Reliability Engineering terminology. So you specify your SLIs, and you can say the objective, the SLO, is either a hard-coded threshold. If you really know, I don't want more than 5 database calls for this feature that I'm testing. But you can also say it should not increase by more than X%. So we basically look at the baseline of the previous builds. So it's great for regression detection. So yeah.
So I find this fascinating, Andreas, because this is something we're also looking at a lot. And I think one of the challenges I see is there's just so many metrics out there. We're in a place where we have probably hundreds of thousands of tests. We have not hundreds of thousands of metrics, but probably a ton of metrics as well. And it's very difficult to know, for example, about more database calls, which are the ones we should defend on. And I wonder if you have a prescriptive list, because maybe, you have 20 years of experience in the space and can be like, heuristically, here's the kind of metrics we should always be monitoring. And that's a good place to start. It's not exhaustive, but
twofold. The quick answer is rewatch my recording, rewatch my presentation with all the problem patterns, because for every pattern I gave you 1 or 2 metrics. The other thing, and I also mentioned this a little bit, because you're right, the more complex our systems get, the more metrics we have. So what we are seeing our users doing, and I'm now talking about the Dynatrace customer base, they're looking at production problems. So they're looking at what went wrong in production, and which leading indicators, which metrics would have told us if we would have looked at them earlier that, you know, if we would have looked at them, we would have prevented that problem. So we basically, you know, analyze, let's say, the last month of problems we detected, trace it back to the metric, and then say, hey, these are the 5 metrics that are leading indicators to the 80% of the problems you had in the last 30 days. So now you are shifting, call them shifting it left, and then monitoring the behavior and the change of these metrics in your CI/CD environment.
Yeah, so to put it in my speak, do a SEV, part of each SEV analysis, part of it, say, okay, what will be the early indicators we should defend?
Yeah. Yeah, or as part of your incident postmortem, right? If you don't have something automated like that in place, right? If you have incidents, then how can, as part of the postmortem, you should not only say how can we fix it, but as part of the postmortem, it's about how can we prevent this in the future. And one thing to prevent this in the future is, okay, what have we learned? What are the metrics? Put them into CI/CD, but also make sure do we have a test for it, obviously, right? I mean, there's more to it. Yeah, but to get started, I think there's a handful of metrics, and I listed some of them in my presentation. Yeah.
So I guess, and how would open source software go about deploying these things? So these, you know, complicated CI/CD deployment stuff. I mean, it's great if you've got a company and a DevOps engineer and your own server. But if you just want to shove it on GitHub Actions, it starts to get a lot harder to do these kind of things.
I disagree, because this is the reason why our open source project is open source. And so everything I talked about today is all open source, right? And the data, where Captain takes its data, by default, it takes it from, let's say, a Prometheus data source. So you can, or whatever monitoring, whatever data source you have, at least in our case, Captain can pull out this data, and it can also then use your open source testing tools like a JMeter. It can use, I don't know, on Kubernetes, we're just deploying with Helm. So you don't need to buy all commercial tools to get a very simple pipeline that helps the developer after they check in code. You have a GitHub action that kicks off that process, and Captain will deploy, test your artifact, and within 5 minutes tells you you have great performance or you have degraded 3 out of your 5 important metrics. So go and take a look at it.
Cool, I might just do that. I'm going to guess you don't have many integrations for Haskell yet, though.
But the cool thing is that it's an open source project, and open source project lives by contributions. Yeah.
Very true, very true. I may take a look at that.
Yeah. So it is spelled captain so KEPTN. It's the German phonetic of a captain. So KEPTN, and you'll find it on GitHub, or the website is captain.sh.
Cool. Those are all the questions from my side. It's about what you guys, do you have any other questions?
I guess I would be curious.
Please go ahead. Yeah.
I would be curious to hear people's kind of favorite performance optimization they've been involved in or seen.
I can share probably lots of stories, but I don't know. For example, so my, I don't know, maybe, you know, it will be sound boring, you know. For example, I spend like a whole year optimizing the Perl bench interpreter, and I was able to optimize it by guess how many %? But
5.
Yeah, less. 4%. Okay.
4%. Why on the Perl bench?
Yeah. It's a Perl bench. Perl interpreter, right? So actually, these scripting language, right? So yeah. Still,
but the thing is, 4% is 4%, right? And if you have thousands of developers using it every day, you save 4% of time for everyone. Sum it up.
Yeah. Well. Okay. So I should say, right. So I optimized it from the compiler perspective, right? So now the compiler is able to generate 4% more optimal code for Perl interpreter, right? Yeah. So, but I mean, yeah, so people are still laughing when I say to them, like, well, and I'm proud of that, right? And they're like, what? 4%? Like, can you spend the whole year?
So I guess I'd be curious. Did you get like 1% every 3 months, or was there one day where you got almost all those 4%?
Well, I don't remember. It was like 2 years ago, but yeah, something like that. Yeah.
There's a great story about the Facebook team that optimized HHVM. I don't know if you read it. Probably you know the guys that created the VM behind it, that is actually compiling the PHP code. So they describe the whole process of optimizing the new VM against the previous one. I guess it was hip hop or something like that.
Probably, yeah. I know they've done some huge wins though, 20% or something, and some of them were from I don't know the details. I know that the biggest wins were unexpected, which is probably how it always happens.
There's a great article on Wired. It was a couple of years ago. So they described that they were in lockdown before the lockdown, the actual lockdown. So they locked down in an office, and they started putting into some post-its on the walls about any possible performance improvement ideas, and then they started doing it. It was great.
I remember my first performance, because Neil, you asked about the story. I was back in the days, I was 21. I had my first kind of engagement where I could travel abroad. And this was for me going from Austria to Germany for a customer. And they wanted to run a 10,000 user load test. And I remember they had like big arguments up front, like, do we really need to buy your professional tool with 10,000 user licenses? And can't we do it just easier? And it was like months or weeks of discussion. Anyway, I get there, prepared for a week of load testing. And we started with my classical test of just trying to figure out, does the system perform with just 2 users? And it failed. So the whole thing was basically, the whole discussions leading up front was just, in the end, really ridiculous, because they had the basic threading issues. They had like nothing was optimized, no thread pools were set, no connection pools, and nothing was configured. Nothing was ever tested other than a single user clicking through the 2 or 3 end-to-end use cases, right? They never thought about sitting 2 users side by side and clicking through it, because they would have found it too. But so yeah, it was a very interesting story. In the end, it was really about configuring, a lot of these thread pool sizes, connection pool sizes. There were some coding issues, obviously, as well. But it was just an interesting experience. And this is why I also say the poor man's load testing tool, this is what I like the most. If you have 2 browsers, or if you have a browser and you hit F5 all the time, this is your poor man's load testing tool, where you can simulate a lot of traffic and you'll find a lot of problems just with this.
Yeah. I guess going back down the memory lane, in my case, it was I was working for a company called UPC, big cable operator in Europe, and they were migrating their user database, and all of a sudden, something that used to take a few seconds was taking hours. So they got one of these DBAs that was like, at the time, 3,000 euros a day. It was like amazing. The guy came in one day. He had like his hard drive with special scripts he was running. He started to change some indexes, and No code change, just index changes in that huge Oracle DB, and then boom, started working again. And I think what happened, they did a big migration, so they doubled the size of the customer base all of a sudden. And some assumptions Oracle had around how they should use indexes versus full scans were no longer true. And everything code to a scratch. Oh. AI has its uses, but I guess there will always be the craftsman, the performance craftsman who will come with their 20 years experience and be like, oh, this smells like an index versus full scan issues.
Although that sounds like the consultant who comes with their pre-prepared scripts and runs the scripts, where if you could have bought the scripts, you could probably run it yourself.
Yeah.
I saw the output of the scripts. It was still pretty cryptic, because I was sitting next to the guy. I wanted to see what he's doing. I was like, okay. There is still some value add from the consultant.
Yeah, in fact, that's also our in a way our approach to combine the two things, because AI alone, without any kind of domain knowledge about the performance or what are the knobs that you are going to touch, what kind of action are you going to perform, it's not going to work. So I fully agree that we need to bring the knowledge, at least the context, to AI to create an effective system. Otherwise, it's very, very hard. It will take too much time, too much issues to just learn in a kind of unsupervised way.
All right, so let's see. Last, I think, Stefano, you had a question that you wanted to ask?
Yeah, when will be the next event? Are you planning?
We're planning to do it every 6 months. So next one probably will be, I think we'll try to aim July, middle of summer. July is when we're supposed to be out of lockdown, no more social distancing in the UK. I don't know how is it about in your parts of the world, but maybe this will be a physical event, at least for the guys based in London.
Oh, nice. I don't think we have any plan yet.
No, I'm just laughing. Neil is laughing as well, because we just had a big speech last night from the PM.
Okay, yeah.
But he's well known for sometimes having to change his mind because the world doesn't function based on speeches. So we'll see. But yeah, we're looking for July. I think pretty soon we'll be reaching out to see if you guys know of any interesting speakers you could invite. So yeah, we'll start organizing it pretty soon.
Okay.
Right. Cool. I would say let's do one last round. Like, what is the biggest performance problem you're gonna start working on tomorrow morning when you get back in the office?
So I can go first. It's not performance. Performance is the kind of thing I do to tinker around the side because it's fun. I have lots of software that doesn't work. I'll be trying to make it work. Once it works, I might do a bit of performance tinkering, but just working.
I currently doing some stuff related to performance stability. So again, topic of mentioned today quite a bit. So how to get stable performance actually will be my challenge.
First thing tomorrow morning, actually, I just looked at my calendar, is because Neil brought it up with the extending of Captain. I know you said Haskell, but I have a call tomorrow morning with one of our Captain contributors. He's integrating Locust, that performance testing tool, with Captain, and we'll do another sync. So really exciting that people are building their own extensions. So in case you are a Locust user, the testing tool, check out the extension that hopefully will soon be ready for everyone.
Nice. So from my side, I'm not that involved in performance. So I'm still working on compilers, but not more of on performance side right now. So so I around maybe a little bit more than a half a year, I switched to another compiler project while still at Intel. And But now it's and we are actually not yet at the stage where we care that much about performance. We are delivering functionality. So at this stage, but pretty soon we will start heavy optimizations. Sure. Yeah.
And we just got a question from the audience, from Raman Pandey. He was asking, do we have any suggestions on connected vehicle performance executions for device to cloud and cloud to device communications? In special, do you know of any open source tool that could help with this kind of scenarios?
I would first ask the question, what's the protocol that is used between the device and the cloud? I would assume it's something that is HTTP based, and with this you have a lot of possibilities then to choose an open source tool that can simulate HTTP traffic. Whether this is the classical JMeter, I mentioned Locust, K6S is another, K6, Gatling, many different testing tools. Again, it depends on the protocol.
And QTT, they just replied.
Oh, yeah. MQTT.
Yeah. Then I would open up my favorite search engine and say open source MQTT load testing. Gatling. Gatling is open source and provides an MQTT integration. So it's Gatling. It's the first thing that pops up in the search engine if you search for open source MQTT load testing.
Okay, so it's the machine gun, right? Gatling.
Exactly, yeah.
Okay. Right, that was a quick troubleshooting right there. But I think, I don't think we have any experience, I mean, at least I don't have any experience with connected vehicles performance execution. I would imagine it's a critical use case though. Right. Cool. Well, I think we're coming at the end of our allotted time for the panel. Thank you so much, guys, for agreeing to have this chat today, and for all your insightful talks. Thank you to the audience for having been with us throughout the day. We had 10 amazing speakers that delivered really hard-earned insights into various aspects of performance, and we're talking about just how wide this space is, right? From measuring the hardware itself versus measuring just what the processes at the very top of the stack do. We'll post our talks to the YouTube channel pretty soon. Like I was saying earlier, we'll have our next Performance Summit in London sometime in July. Stay tuned, let you know early enough. With that, sunny London, I bid you all a great afternoon, and see you soon.
Thank you. Bye-bye.
See you soon. Bye.
Bye.
Thank you, guys.
Bye.